Water is in constant supply in mining and in the construction of tunnels, roads and buildings, and must be continuously pumped away. In this video, we take a look at how to effectively deal with the water seeping through cracks in the rocks in mines and wastewater from the mining process. Water is often used for cooling drilling machines or as an ingredient for mixing cement. During these processes, the water becomes full of small particles, which are very abrasive, causing a great deal of extra wear on a pump's impeller and the other parts in contact with the water. The harsh environment of underground mining with stone, grit, cramped spaces and limited lighting makes it difficult to handle machinery and equipment. This machinery and equipment has to be extremely robust to withstand these conditions day after day. As level sensors are often impracticable in the difficult terrain, pumps working in these conditions are sometimes operated manually and left running. This means that even when the pump has emptied the sump, the pumping continues indefinitely. Consequently, due to this ineffective use, pump parts wear out much quicker. It also uses up much more energy than necessary. Here we can see a pump snoring once it's emptied a sump to the required level. From this moment on, the pump is no longer productive, using energy unnecessarily. Water still remains in the hose and particles begin to settle, collecting in the pump hydraulics, where most damage can be done. As long as the pump is in snoring mode, these particles remain in the hydraulics, causing excess wear on the impeller, suction cover and seals. This ineffective pumping is usually the highest contributor to a pump's running costs. The best solution to this problem is to connect a Flygt FPC100 controller to the pump. This is specifically developed for economic and environmental operation. It can start and stop a pump without level sensors, and it has built-in alarm functions offering even greater protection to the pump. The FPC100 is small and easy to install into almost any control panel. Rather than level sensors, it uses the power output from the motor as a signal to stop. The output is continually calculated based on the voltage to the pump and the current, which is measured with a transformer. After connecting the controller to a pump in a water-filled sump, a simple touch of a button at start tells it to read the motor output. After this, the pump can be left to run, as the FPC100 will then take care of everything automatically. The pump performs its job of emptying the sump, and at this moment the effect curve is stabilized. When the water level has reached its lowest point, the pump begins to draw in air and snore. The controller registers the reduction in power output and stops pump operation. The FPC100 immediately calculates how much time should elapse before the pump starts again. The controller does a rough calculation on the flow of water into the sump and adjusts the stop time accordingly. Whether the inflow of water is fast or slow, the pump stop time is adjusted accordingly, resulting in the same approximate start level time after time. The start level can be adjusted by scaling the stop time. Other parameters can also be adjusted if required. Wear and energy consumption have been compared in different studies with and without the use of the FPC100. The results showed that by using an FPC100 there were up to 60% savings of the energy used, 70% savings on wear on hydraulic parts, and 50% less maintenance costs.